So this is not about music, drums. Originally, when we started working on this project, it had the acronym, the Dyalog Remote Communicator, DRC. I didn't really like that, and it's also the initials of the Democratic Republic of Congo. And that started a train of thought which ended up with conga drums also being a form of communication over long distances in the jungle. So the product, and then it was called Congo, and then we decided it wasn't good to have the same name as a country, and the drums were nicer. So Conga is a tool for remote communication. How many people here have written tools to communicate using TCP/IP or over the internet? Quite a few. And how many people have written a web server? Oh, not bad. In APL? Okay. Okay, so you will know quite a bit about these, or something about these communications. So Conga is a tool for remote communications. I'll introduce that first. And then talk a bit about secure communication, which is becoming more and more important for people. So it's easy to put up an APL web page today using TCP sockets, but it's becoming more and more important to encrypt the communications and be sure you know who's at the other end. And then finally, spend a bit of time showing you a tool that's been developed at the moment as an APL workspace, a prototype, a way to deliver something called a web service, which is a bit different from a web server. It's a form of remote procedure calling over the internet that's also becoming very important. So Conga replaces TCP socket objects that many of you are already familiar with, I think, as the preferred or the recommended tool for internet or TCP-based communications. And why are we doing this? Well, TCP socket objects are very general and quite close to the underlying TCP protocol. And we found our experience talking to people who write applications and writing applications ourselves is that most APL users only use a small subset of the features of TCP socket objects, and in fact have quite a bit of trouble dealing with the creation of TCP socket objects and correctly handling errors when there are, which there always are eventually. If you open and close enough sockets, there'll be a problem. And then finally, the fact that TCP sockets are in fact seen as a kind of GUI object, and that you dequeue them together with your GUI objects, means that it can be quite tricky to build a GUI application which also uses TCP communication, because you can get confused about whether you're dequeuing the sockets or the GUI. So that was the motivation for building a slightly higher level tool. And I'm going to dive straight in and show it to you. Are there people here who have actually used Conga? Oh, all right. Quite a few already. Okay. So here we go. Quick introduction to Conga. I mean, this is a tutorial workshop, so please stop me. If anything is unclear, stop rather than just letting me continue. It's better that we get halfway through the material and everybody followed it that far than me just wading ahead. Okay, so I've just copied disp. I've set up a variable that I'm going to need. So the first thing you do is, the namespace is still called DRC, so you can see the origins of the story is still visible there. So DRC init just loads Conga, which is a DLL. And it's going to be available on all platforms with version 12.03. As the ports are done, Conga included with the product.
Yes, and that's 64-bit too.
64-bit, Unicode, non-Unicode. I don't know that we'll do one for the Pocket PC. I haven't thought about that yet. Actually, we will, won't we? Because Gilgamesh needs it.
I need it.
Yes. Okay. Okay. The argument there, Björn, is where to load it from, but there's a default. Okay, so let's create a client. If you've used SQAPL, you may recognize the sort of the way arguments are put together. This is not working. So the first argument is just a logical name like a tie number, except it's a string, C1, client number 1. The second argument is the IP address or name of the... This is an upside-down mouse. The IP address of the name, the port number that you want to connect to. 13 in this case is on many Unix systems something called the time of day server. Text means it's a text mode connection rather than an APL connection, and 1000 is for a text mode client just the size of the buffer that you want created to receive incoming data. And then I'll call DRC wait on that, which immediately returns because the time of day server is, I think it's available on virtually any Unix. You connect to it, connect a socket to it, it immediately spits the time of day as a character string into that socket and closes it. Okay, so that's sort of the simplest imaginable use of Conga, is to connect to one of these kinds of services, you get some data and the socket's been closed. Yeah. And you could connect to a web server. So that's Dyalog's web server on port 80, a larger buffer. This time we'll send something rather than just waiting for input. So we send the string that a web browser would send if it wanted to get the front page. We get back a connection a connection object. How is it? Yeah. And wait on that. And we've got back now a return code as the first element. The second element is always the object name on which the event occurred. The name of the event, in this case a text mode client, we've received a block of data, and then let's just take the first 100 of those. The first 100 characters of output from Dyalog's web browser. We can wait again and receive another block and so on until we've received all the data and close it. In addition to the block event, there's a block last event which tells you that you received a block of data, and before you asked the question, before you entered the wait, the server had also closed it. So you know that that's the end of the communication. And in the Conga workspace, there's also a bunch of utility functions like HTTP GET, which is just a simple cover on top of what you've just seen, except that it does a little bit of processing of the HTTP that you get back. So there's a return code, and then there's headers. It knows a little bit about what HTTP looks like, so it's extracted the headers that came back from the web server, and then the data. Okay, so if you compare this to doing it with TCP socket objects, there's not a huge difference. I mean, it's sort of the same kind of steps you have to go through, but I think I mean, you would normally have written some APL cover functions to get to this level of use of TCP socket objects. Here, all of that business of creating the socket, reacting to the connect event and so on is hidden down in a layer of C code in the DLL, rather than being something you have to deal with at the APL level. And all the errors that might occur and so on are caught by Björn in his C code, and the socket is, if necessary, closed down cleanly and so on. Okay, now if we want to be the server, instead of calling the DRC client function, we call one called DRC server. And the arguments are pretty much the same. It's a name that we want to refer to it by. The port, not that we want to connect to, but that we will be listening on, because we're a server. And then the same, we're a text mode server, and our buffer size is 1,000 bytes. So the buffer size essentially is the largest block of data that you could receive when you're on a wait. We'll never return more data than that buffer size. We wait on the server for 1,000 milliseconds, and of course nothing happened. Now, I hope this is not confusing. Everything that the server is doing is indented to here. And I'm now going to do some client operations in the same workspace. So I'm going to be client and server just here in immediate execution. Everything that a client does is going to be aligned on the left-hand margin, and the stuff happening on the server is in the middle or on the right. Okay, so we make a connection to localhost, which is my own machine. On 913, those numbers have to match, and we make a text connection. Now the server has gone into another wait. It's sort of, typically a server would wait with some timeout, and then every second or 10 seconds it would wake up and decide whether it needed to do housekeeping chores of one form or another. So we wait, and we now have a connect event and a command object that has been created as the child of TOD. So this notation here, TOD dot, and then this here, that's just a name that has been generated for this connection. And at the moment, we encode the IP address of the partner into that name. And I guess this is the local port that was used remotely. So we don't currently have a way to query the object and ask what is the IP address, but we won't change this. We certainly won't change this name format without providing that functionality at some point in the future. So the server then, which is, we're emulating a time of day server, and I predicted that fairly well. It's only a minute out. Responds. And the client then was waiting on the C1 on its connection, and it receives the data. So this is essentially the same as before, except we were both sides of the connection. Okay, and the server then eventually shuts down and closes its object. Okay, so we provide as a sample in the Conga workspace a time of day server example. So now, you see, I call that with an ampersand, right? So we're now starting the time of day server. The argument is which port to run on. And it's starting in a separate APL thread. So we can see, well, there's not much point really tracing this. You've seen all the steps. It creates a server. And then it goes into a loop where, while not done, it does await 1,000 milliseconds. And then typically a server would have a block like this, where it waits for 1,000 milliseconds, or a maximum of 1,000 milliseconds. Of course, as soon as there is an event, it comes out of that, and then it looks at the event. If it's a connect event, it then formats the time, sends it back. If anything other than a connect occurs, it says, well, I'm just a time of day server. I don't deal in anything other than connect events. When I get one, I send back the time. Anything else, I'm just going to ignore it. Just close the object. And then if the return code was a 100, that means a timeout. So DRC wait, the first element is a return code, which is 0 if all is well, 100 if it's a timeout. And then we might do some timekeeping down here. So this is the general structure that a server function would have. So I'll press the green button here to resume all threads and make a client connection. Wait for it, and we have a fully functioning time of day server, which we started on port 913 so that it doesn't conflict with the real one on port 13. Okay, and the server looks to see the variable when it times out every second. It looks to see whether we're done, and it ends. Okay. So far everything we've done has been in text mode, where you're just sending strings and receiving strings, and if there's any protocol there which marks the beginning or end of a transmission, you're responsible for searching for it. Now, like with TCP socket objects, there's an APL mode, or a command mode we call it, where in fact, that's the default mode. So if you create a server and you don't say that it's in text mode, that automatically means it's in command mode. And everything works exactly the same way, except that you're now sending entire APL arrays at a time. Now, a command mode socket deals in logical commands. It's not just receiving blocks of data as a stream. It's actually receiving numbered commands. It receives an entire APL array, and it can then respond to that. The downside of that is it can't simply respond to a connect event, because it doesn't have an incoming command to respond to. At least that's the way we've architected it now. So the APL mode time of day server actually has to wait for the client to send something. And when the server waits, this command object is created. So command number 1 on this connection is created. And the data element of this result now could be any array. We just sent a string here, but the server responds. Instead of formatting a string, it just responds. Instead of calling the function drc send, it calls respond to a particular command. And the reason why we have this command thing will become apparent a bit later. It's so that you can have several commands going in parallel, asynchronously. Okay, so this is also clear now that people are starting to fall asleep, right? No questions. It's just, I should speed up. Okay, so we have an APL time of day server, and I'm not going to trace that because you know what it does. It just starts the server in command mode. But now I'm going to exercise it a bit more. I create a connection to it, the C1 client, and then I ask it. And here I give this connection the command. I can decide what name I want to give it. So I ask it question number 1, what time is it? And then I ask it question number 2, what time is it? And these are now 2 logically different commands that the Conga protocol in command mode is capable of keeping apart. So I could now say, well, I want to wait to the answer to question number 2 and get that, and then ask for the answer to question number 1 afterwards. And you can see that that is indeed, this is the first one, right, 2 seconds before that one. So it did give us the answers in the correct order. Or I can do something like this. And the reason why we want this to work, of course, is that you can fork off things running on multiple threads, and they can just, at a logical level, they can ask questions about worrying about whether they're in conflict with other things happening at the same time. And that again is something that's quite difficult to do with the TCP socket objects. So here we've asked 4 questions, and I'm now going to spawn 4 threads separately to wait for the answers to these questions in a random order. So that's, and we get the answers back. So one of the motivations behind the design of this is that you want to be able to write multi-tier applications where you have maybe an APL component that's receiving TCP requests incoming and then spawning different threads to deal with those. And those programs which run in order to get the response to send back to a client need to make TCP requests of other services above them in the hierarchy. And as Stefano knows, that's a little bit tricky to do in the current model. Whereas here, it's trivial. You just give these things names, and Björn sorts everything out. And Kai has called it a trillion times, and I think most of the bugs are out. But that, I mean, getting this stuff to work multi-threaded on the C side, of course, the C component of Conga is multi-threaded. Okay, so one of the things, I mean, that's really all there is to using Conga. You don't need to know more than this to use it. Does anybody have any questions before I show a sample? Yeah, Robert?
Actually, I have 2 questions. Can you specify what IP was your multi-home machine?
No, we do not do that. So you can't have.
Say we have a router machine with incoming and outgoing.
Yeah, we have actually thought about that. We have discussed that. We haven't implemented it. So that's. Are you taking notes, Björn? Yeah. Would that be important?
I see it.
Yeah.
The second question, is it IP6 ready?
No.
Yep.
Okay.
So, question: if I want to get I want to just get the next open port, in my environment. You guys, you did that.
The next open port for a server?
Yeah. Well, not the server. The server
Yep.
decide on one port to actually use because that's one the rest of the world should know to connect to. Yeah. The client would also have a port number, but that would be the first one free. That's right.
Yeah, that's automatically allocated by the TCP layer. Yeah, I mean, no, we don't have something which would search for the next available server port in a range. But I think that's a rather odd thing to do.
No, it's not at all. You have to do protocol forces you to do that.
In active mode.
It's supposed to, yes.
You can open.
Okay.
You can open one server.
Yeah, I mean, you could do it for load balancing. Yeah.
In fact, the port that you're going to ask them to open.
Yeah.
Yeah. That kind of a list. We're going to communicate across this. So
Yeah, but okay. I mean that the active mode FTP uses 2 sockets, right? You connect on one, it tells you I've created a server on that port, and let's go and talk on that channel.
Correct.
Yeah. Okay. So Björn's taking notes.
I expand a bit on that last block thing.
Yeah. Well, block means you receive data, but at the time you asked the question, you called wait, and the block, the block arrived. The time that wait decided to return to you, the socket was still open. Whereas block lasts tells you that when you called wait, there was data for you, and the server had closed the socket, subsequently closed the socket.
So he's issued a shutdown.
Yeah, we don't Björn, can you answer that?
I was taking notes. So I didn't hear the question.
When you get the last block message, does that mean the other end has issued a shutdown, but you can still send data to it. I sent my last message.
I think it is actually shut down, but it's lingering.
Yeah.
So, but the server would not expect you to send more data since it's shut down and lingering.
My understanding is when one side issues a shutdown, it says receiving data as long as you send it to me. When this side then issues a shutdown, they both agree there's a thing's finished.
Yeah, I think what we do is when we receive the shutdown, we also close the socket. But Björn has been collecting the data behind the scenes, right, of APL. Björn's been buffering the data. You know, we don't just go and look on the socket when you call DRC wait. The Conga is running, you know, in the background, constantly collecting data. So it's received the data, the server shut down the socket, we've reciprocated by shutting down the socket. But from the APL user's point of view, there's uncollected data in the buffer. So when the APL application decides it's time to go and ask for data, we can inform it that, you know, the last bit of data has arrived and the socket's been closed down. But we don't consider that to be an error condition. That's a normal thing.
That's normal. It's whether you can still keep sending.
No, you wouldn't. No.
He has promised not to send you any more.
After you've received a block last, you cannot transmit.
You try to send something, but you get an error message.
Yeah. Yeah. Okay. So one of the samples we provide then... Oh, well, Stephen, did you have a question?
I think they just got answered.
Okay. So one of the samples we provide is an the wrong cross. Is an FTP client, and so I'm going to connect to something called ftpmirrorservice.org, which is a public FTP server. And here's the name of a folder and a file that I'm going to get out of it. And this is implemented as an object, so that you make a new FTP client, you pass it the host user ID and password, and that uses Conga to make a text mode connection. And then we call the FTP client class has a list method that you can call, and it tells you what's in this pubs folder. And if the name of the file is not in that result, we give an error message. Otherwise, we call the get method. So there's a very simple FTP client using passive mode that can both get and put data to FTP servers. Okay, I think I won't do that. Yeah, so those of you who saw the presentation I did with this model of a parallel, a mechanism for parallelizing APL expressions, where you create a remote namespace. That was all done using command mode Conga socket, but I don't think we'll trace that right now. Okay, so
you're passing messages back and forth. You're not going to share memory.
no. Every APL expression that I was typing there was caused I had two remote namespaces, so a command was sent to both of those remote APL sessions, and the answers were coming back. And I mean, you really couldn't tell. TCP is so fast on machines today that there's really, you don't notice making TCP calls unless there's a substantial amount of data going backwards and forwards. Okay, so yeah, just to show the documentation for Conga in version 12.0, you may not know this, but there's a menu item called Help, where there's a new item, Documentation Center. This is new in version 12. That takes you to a web page which is just part of the Dyalog installation, an HTML file. And it contains links to all of the sort of the main 5 manuals, and then also version 11 release notes, and a bunch of tool manuals for SQAPL, and Conga is one of the manuals that's on there. So if you ever need to find documentation now from version 12, try Help Documentation Center. If you're not in the product, the same web page is available at dyalog.com/documentation, and all of the manuals are available in PDF form online. So there's really no reason. Let's see. Let me just show you that, because this is really worth, if you haven't seen it. So documentation brings up this same page on the internet, and also if it's language help you're looking for, dyalog.com/help has all of the online help that you would get from the help menu converted to HTML, so you can search it and browse it on the internet. Okay, so that was the basic Conga. We think it's easier to use than TCP socket objects, and it's one of the goals in the design was to support these multi-tier, multi-threaded applications. And now it also supports secure communications. And there are a whole bunch of coding samples. So whether if you want to build one of these components here, they're all available for you to look at and start customizing for your own use.
So the socket objects, what's going to be happening with them?
Nothing's going to happen to socket objects. We continue to support them. We may upgrade them to IPv6 and other things like that. We're not planning to add secure communication, and we're not planning to do any significant upgrades to them, because we think people should be able to. The people who have converted from TCP socket objects to Conga so far have said that was almost a trivial thing to do. Delete lots of code, put in a few lines, and the application was up and running. So we're hoping that TCP socket objects will slowly or quickly fade away. They will slowly fade away. Yeah.
TCP sockets on a Windows machine. Windows comes with TCP sockets. It's built in.
It's built into every operating system on the planet. Yeah.
Is that already built in, or is it only this time?
Conga is built into version 12.0.
But it won't be on. It's part of Dyalog.
Yes. Yes.
So, and it's a DLL.
It's a DLL which moves data as APL arrays into and out of the DLL. So it's not something you could easily use with other programming languages.
So it's a DLL I'll have to install on my client's machines if they want to use it.
As part of the runtime application,
Right,
yes.
And that's, in which case, I've got to use TCP/IP still, because the client won't let us put in DLLs on their machines. We have no DLL. We can't put a DLL on our client machine. It's not part of the...
You can put an executable, but you can't put a DLL.
Yeah. The client is a DLL. We can load an executable.
Yeah.
But DLL...
Really?
We're not allowed to install anything of that sort. We don't install the executable on the machine. It's a virtual machine. It just loads it from the server. DLL. So, the executable. We don't load any DLLs.
But you're allowed to do a Dyalog installation on the machine, right? No.
Runtime. It just the runtime exe is on the server, and
Yeah.
we just load it. Nothing installed. It's a zero. It runs finishes zero.
DLL is on the same server, just next door to the next to work as well.
I can't run the DLL on the server when the executable is running on the machine.
It'll pick it up from the server class. That works.
That should work,
You
yeah.
don't have to install the DLL.
Yeah.
It just has to be in the same directory as the X.
Right. Okay. I believe
Yeah,
it.
that's part of looking for a named DLL on our Windows platform. Is it will look down your path and then into the directory it's got your executable from. I think that's the right way around.
Okay.
But
Yeah.
actually, the location of the DLL is specified in the init function of Conga. So you can change that to put it alongside the executable or somewhere, wherever you want. You just need to remember the path and put that into the init function. It will load the DLL
Yeah.
from
So
there.
when you're running a Citrix server, the Citrix server is loading the executable, it will,
Yeah.
the Citrix server will also load the DLL.
I can't remember if there's some trick with marking DLLs read-only to get them to work, to avoid Windows locking them or something like that. But I mean,
You can call something else than a DLL. You'll probably load it anyway. You don't need to call it as an extension DLL.
yeah. Anyway, I mean, but this is, I mean, there's an interesting question here. You know, should something like Conga be an integrated part of the language?
Yes.
Of course, going forward, one of the things we think we might want to do with the product architecture in general is to split it up into a bunch of DLLs like all other software products in the world, so that, you know, Dyalog.exe would no longer be a 4 megabyte thing. It might be a, you know, 1.5 megabyte thing with just the core language, and then the IDE and everything else would be DLLs that would get dynamically loaded.
So the ID isn't used in runtime.
No, but other components might be. Yeah. So I mean, it would be a normal thing that, say, the ODBC interface and the various other interfaces are DLL are libraries.
Anything onto the Citrix server, it has to go through weeks of testing before it's allowed to be put on. And it's not our testing, it's
Yeah. Okay.
The smallest number of units is
Yeah.
better in those terms.
Yeah.
But
Okay. So I mean, we may well decide to integrate Conga. You know, if lots of people start using it all the time, which I guess we do expect, the way things are developing, it should eventually become.
would it be feasible to have alternative shippings? You might have this one XE or
Yes.
small XEs
Yeah.
and several DLL.
Yeah. Yes, and I mean, people are also occasionally asking for the workspace also to be integrated into a single executable, so that people can't see the source code. You just ship a single executable to people. The only thing that it can be used for is to run that application. Yeah. Okay. Tommy.
Will it be possible to use Conga from within IIS?
Yes.
I have tried.
I don't see why not. People can certainly use SQAPL from inside IIS and do. And the architecture is the same, right? Except it's multi-threaded and stuff, but so what?
I've tried to use TCP socket, but it didn't succeed.
There have been problems with TCP socket objects inside IIS. I'm not sure whether they are resolved. I don't remember. But I think Conga, I don't see why it should not work. It's just a DLL. The problem with TCP socket object was exactly that you were dequeuing stuff inside what was a callback from IIS, and that was sort of a questionable thing to do. Okay. So yeah, the version of Conga that, if you got version 12.01 for Windows back in February, the version of Conga that came with that did not support secure communication, but the production, so the Platinum final version of version 12.0 released in August does support secure communications. And what's the point of secure communications? Well, you can be sure that the messages you transmit are only read by whoever it is you intend them to be read by. And you can identify with, if you trust the certificate authorities, who issue digital certificates, you know who's at the other end of the connection. And messages cannot be tampered with on their way to you. Yeah, the sequencing of the bits here is... There's some interesting stuff coming down there. You'll have to wait for the text. So this is all based on something that used to be called SSL. I believe the correct technical term is now TLS, but it's the same thing, right? Transport layer security. And each player who wants to participate in this secure game needs three things. Well, three things. They need a public certificate which they send to anybody they want to communicate with, or make available to people they want to communicate with, and they have a private key and a collection of root certificates from certificate authorities that they use to do some math which allows them to be sure that the whatever keys and certificates they get hold of are valid. So what you do is you send, as I said, your public certificate to the people you want to talk to, and you keep your private key secret. And I don't understand, this is all about prime numbers and hairy mathematics, but the point is that you can encode information using one of these things. It can't be decoded with that thing you use to encrypt it with. It can only be decoded using the other one. So you keep one, you give people the other one, and then if they want to send something to you, they encrypt it with your public certificate, and you are the only person who can decrypt it using your private key. If you trust the certificate authorities, the people who issue these certificates and keys. And there have been cases, I don't know when the last scandal was. There were, I can't remember who it was, but somebody issued a bunch of Microsoft certificates to somebody who sort of phoned them up one day and said, "Hi, we're Microsoft, we need another 1,000 certificates." And people were then able to put up secure servers which identified themselves as Microsoft Corporation. And if you used, the software to validate that the keys were correct and so on, you would therefore be completely convinced that you were talking to Microsoft's server. And that's what these companies get their money for. We've purchased some certificates. What they do is you submit a request for a certificate, and then later somebody calls you up from America and says, "Hi, is this Dyalog at, in Bramley?" And you say yes, and then they decide to issue you with a certificate.
That didn't leave me feeling...
I mean, I'm sure there are different levels of these certificates and so on, but anyway, that's something you need to talk to your system administrator, the guy who looks after the keys in your company. So if you want to publish a service, if you have a web server or a web service that you want to publish, you have to apply for one of these things. Get a certificate so that your web server can be certified. Okay, so the certificate authorities, there are some of their logos down there on the right. There's a whole bunch of different companies who do this. And they issue root certificates that can be used to match up, to validate the user certificates. Now you can, if you're just doing this for your own internal use, say you're just experimenting, you can easily, with I think any operating system these days, generate your own certificates for testing. And Conga comes with a bunch of test certificates that we'll use in the demo here, but of course you do not want to go into production with those certificates.
Yeah, you can get them off the internet.
Yeah. Okay, so I mean, I don't understand the mathematics or exactly how the validation of those certificates works. But as Arthur C. Clarke says, that just means you trust it. It's magic. It's easy, and you just use it. Where was this again? secure intro. So here we go. Okay, so this is just using Salt simply to open Windows Explorer. There's a tricky way to do that from APL. I just asked it, Salt, to explore this folder. So we, with Conga, you get a bunch of certificates. You get a server certificate, or a couple of server certificates. You get some client certificates called John and Jeff and things like that. And we ship the okay, this is actually in my test folder. We ship a set of, let's see, where are those? Public certificates from the certification authorities that were, the valid set of certificates at the time. Certificates are they're validated with a root certificate, and every certificate that's issued, of course, has an expiry date to make sure that you have to typically renew these every year or two, so that if there is this kind of problem that bogus certificates get issued, they will eventually expire, and the world will get cleaned up. But if you want to go into production, you can play with these that we issued, but you'll need to download fresh certificates when you start using this stuff. Okay, stuff all over again. So how do we make a server? Well, we need to know where the certificates are, and in the samples there's a little utility function that finds that folder that I had trouble typing in there. And then you need to have a server certificate. So I've picked our trial certificate and the key to it. And then I'm going to create a secure client as well. So I'll pick the Jeff certificate and so each one of these certificates or keys is just a file, typically with an extension like .pem. If you look inside, you'll see a bunch of hexadecimal numbers. So we initialize Conga as before, and then before doing any secure stuff, we have to tell it, well, where are the root certificates, so that if it connects to a remote service and receives a certificate, it can validate it using the root certificates that we have. And then instead of server, there's a function called secure server, which has the same parameters as before to begin with. So I'm going to call it stats, my statistics server, on port 1234, and then the pointer to the file and a flag 64, which I don't remember what is. It's something about when you receive connections, you can decide whether you require validation of the client. For example, you can be a secure server but not require the clients to be secure. Typically, say when you buy a ticket from an airline online, you go to a web page which is secure. That means you know who they are, so you feel safe typing your credit card number in when you get to that point in the transaction. They don't care who you are as long as they get your credit card number. So very often you'll have connections where the server is secure but the client is not. And this argument here, I think, says don't validate, don't require client certificates or something like that. There also, we'll see those a bit later in the presentation, there's a whole bunch of flags. You can say accept a certificate if it's expired, accept it if it's, various other ways that certificates can be questionable. And the client then is the same as before. You call secure client, and in addition to the usual arguments, there's the pointer to the client certificate and the client key. The rest, but once you've done that, the rest of the Conga communication is exactly as before. You wait, you send, you respond, and so on. You have a couple of additional things you can do, like the connection has been made here, and you can say get a property of the connection object that was just created, and one of the properties you can request is the peer certificate. So the server is asking, give me information about the certificate at the other end of this connection. So this is the information about the certificate that the client presented. And these abbreviate, that's country, O, organization, organizational unit, name, certificate name, user ID, subject alternate name, when it's valid from and to, and that sort of stuff. Okay, but then you send stuff, the server waits, it receives the data, responds with some data, we wait for it. The rest of it is just the same as before. Okay, so any questions about that stuff, or is it just? It's very. I mean, if you trust the basic mechanism, which you sort of just have to do, the rest, it's simple after that. Kim?
But the client does not need the certificate if the secure server does not require it. Is that right?
No, that's correct. Yeah. And those are the flags that you can set. Don't require it. Require it, but don't. Was it? We'll see a list of flags a bit later. Yeah. But it's up to you to decide. You can also say don't do any validation at all, but give me the information about the client certificate, and then you can look at this information and decide, make your own decision about whether to accept the connection or close it again immediately. Okay, so let's make a very simple web server. That's again one of the samples that Conga comes with. So here's a callback function which is going to be used inside there's a very simple framework where when an HTTP request comes in, it's going to call this function, and you can write your own function, whatever you like. That function will have an argument which is a little object called CMD, the command, and some session information. And into there it will have put stuff that we can look at. So we can get the command and the page. The arguments, that's the stuff that was with ampersands, for example, on the HTTP command line. We can get the username from certificate information on the session. And then it's building all that into a little matrix. You can see a 2-column matrix here. And then calls a little utility function to format that as an HTTP table. Oh, and into the session it's output its argument. Oh no, it's output this result into the session. So we're going to fire up a web server which just calls this function every time there's a... and then there's a whole bunch of stuff down here which we won't look at, which formats this nicely with colors and stuff before outputting it. Okay, so we'll run that with an ampersand, so it's running in this workspace but in a separate thread. And then we'll make a secure client connection to it. And now on the client side we can also ask, well, give me the peer certificate information about the server. So we can see this is the a server that was started using the test server certificate issued by doesn't say. And then you get not only the information about the certificate itself, but the signing chain, the certificates that were used to sign it and validate it. So this was issued by the test certificate authority, which is Jonathan, I think. And like the HTTP GET function, there's an HTTPS GET, which is going to make send this HTTPS command to our server, which is listening on port 8080, and it's going to say, give me the page foo with these parameters. Okay, And the output we saw there was that server function echoing into the session the data that it had extracted from the command and the session. And we got back a return code, the headers, the certificates, and the data, which is not very easy to read, but of course we can create, and this is a .NET WinForm. So I set up QuadUsing here to give me access to the .NET framework. Make a form object, make a web browser object, which is also a standard component. And of course, an APLer would have written that as a one-liner. Give me a form and a web browser, calling QuadNew each. Set the size of the web browser and the form. Add the web browser to the form's controlled collection. Set the document text property of the web browser object to be this data that we just received from the server, and show the dialog. So that's the nicely formatted HTML that the server produced. So, I mean, again, this is something that a lot of APL programmers are not aware of, which is that it is trivial to write an HTTP server, because the complexity of the minimum set of HTTP and HTML that you need to produce in order to satisfy web browsers is really very simple. And the sample HTTP server and functions like, format as an HTML table, those are all just little functions with 50 lines maybe for the server. It's that order of complexity. So, and now that you have secure servers, you can actually, I think that opens up the possibility of exposing APL functionality securely, safely, in ways that I think a lot of people should really take a look at. So here's a statistical calculation function I've written. So this might, I'm a statistician. I've written this very clever function to do statistics on numbers. It tells you it calculates the mean, the median, and the mode, and the count. So I've written a secure callback function that I'm going to use to serve up this data. And what it's going to do is this is the same as the one before, so it receives the command object and the session object. It has a look at, it extracts the user from the session's peer certificate, and if the user is not Jeff Sample, it says, oh, the HTTP return code is 401, which means unauthorized, and it exits. Otherwise, it looks at the page name that was requested, and if that is /statcalc, it calls the clever statistical function, appends count, mean, median, and mode. If any kind of error occurred, it says failed and the diagnostic message. And then it calls this HTTP, formatted as a table, and the nice formatting again. So I'll close the HTTP server and start a new one on the same port, which is just using this statistical so it's now a statistical web server. And if I call that, it'll crash because there was an error in there. One day something's going to go horribly wrong. We're going to assign a meaning to jot alone on a line. And everybody's code is just going to run straight through these lines of code. So what do? We extract the user. It is Jeff. CMD, so this command object is it's a very simple APL framework that's handled the HTTP and extracted the so the arguments arg 1, 2, 3, 4, that's just what was there on that line. Arg equals 1, 2, 3, 4. So it's done a little bit of that processing just to make it really easy for an APL programmer to handle this kind of simple HTTP request. So you can have something which isn't, you can implement function calls as this kind of HTTP request. You don't have to put up an HTML form at all. You can just say, I have something called statcalc, and if you call it with, arg equals 1, 2, 3, 4, it'll do the statistical calculation, format some HTML, and throw it back at you. Okay. I think that timed out or something like that. Probably. Let's see if we can do this again quickly enough. Yeah, we got it. Oops. That. So, there is the data. And of course, you don't have to format that yourself. You could... Okay, this is just to get hold of a function called process start. And when you launch a process, it looks at that, it says, oh, that's an HTTPS request, so let's start the default web server. Okay, there's a problem with this website security certificate. More information. C certificate. Okay, well, the reason for that is that Jonathan's certificate is not installed in a place where Internet Explorer can find it. So Internet Explorer doesn't know about the test certificate authority. It's gone to a web page. It's been told this was, the certificates, the server certificate was signed by the test CA, and it says, somebody may be trying to fool you. So that's what this thing means. If you go to a web page and you get it, it's because the certificate was not issued by a trusted certificate authority. And that may be a configuration error or not. But anyway, you can tell it, well, continue to this website anyway. Okay, so we continue to it. And now we still have a problem. Okay, let's get rid of that line and continue. Unauthorized. Rats. That's because it's Internet Explorer also doesn't know to use the Jeff sample certificate when requesting this page, but of course I can comment that line out. And I now know.
Removing all security.
Now, hey, it's still telling me there's a certificate error, but so we could change this. Oh, fantastic! Isn't that cool? This started happening. Okay, so this is just to prove this is maybe this is a good time to take. We've done an hour. Let's continue at 1:15.